All right, we're continuing on with lesson 10.2. I like to do the next few examples, 11, 12, 13, and 14 in this video, where I'm going to show you how to sketch polar graphs. Now, we'll use a calculator for sure, but I want you to know how to do this by hand as well, so you see the actual graph appearing. So to help you with this, if you are in my class, if you can turn to the supplemental notes again, yeah. And we'll continue on because I only did the first part with you. But now I really want you to recall how to graph or sketch out the basic graphs of sine and cosine on this grid. I hope you remember that once again, the sine values are the y values. So I'm just looking at these highlighted y values. So 0, half, root 2, root 2, root 3, root 2, and 1. Notice that goes from 0 to pi over 2. So if I were to plot those, here we go. Pi over 2, and then we add 1/2. Right, like you get this. And then hopefully you'll see that it comes back down to pi. And then all the way to -1 at 3 pi over 2, and then back to 2 pi. So once again, I should label these as my scale. And then red is y equals to sine theta, where the blue graph, what I'm using now in blue, x values, we'll start with x is 1. And then it'll go down to 0 like this. Hopefully you remember that this looks like the cosine graph. Okay? So we're going to use this idea, okay, to help us graph polar functions. Remember now, with polar functions, our variables are r and theta, where the dependent variable is r, okay, and our independent variable is theta, okay? So if you turn the page, let's take a look at how we can sketch these again. Same as the one in your, not section 9.2, this should be 10.2 notes. So 11a is r equals to 2 cos theta. So what I'd like you to do first with all of these is just imagine that I asked you to graph out y equals to 2 cos theta, okay, on the, or 2 cos x if you wanted to be, okay, on the x and y axes. Okay, so can you do that for me right now? I hope you can, because it's the cosine graph, right? And that 2 just means it's a vertical expansion by a factor of 2. So you're going from here at, I'll call this 2 now, down to 0, down to -2, back to 0, back to 2. So that's what the graph looks like, right? Now, if you were to make a table of values, sure, you can do that. Theta and r, if you think about it, or remember, theta is like your x. Theta is like your x, yeah. R is like your y. And if you wanted to do it this way, then when theta equals 0, the r value is 2. Just some key points I'm going to do, right? Pi over 2 for the x is 0. Pi is -2. 3 pi over 2 is 0. And of course, 2 pi back to 2. So, what's next? Guess what? A, B, C, D, E, and I want to show you how these points now are plotted on the polar grid. So the coordinate of A, which is 0, 2, is now represented on the polar grid as, okay, once again, 0, 2. So theta is 0, the r value is 2. So here is point A, okay, right there. Okay. Now notice at point B, we're at pi over 2. So I'm actually rotated all the way from here, all the way to pi over 2. That's this point here, or this spoke. And then it's actually at 0. So the actual point that I'm using for B is actually here. Now, how did I go from A to B? So remember, as the angle increases, okay, notice the value of the r decreases. So it doesn't stay here at 2. That'd be too much, right? It actually decreases. It decreases all the way to 0. So hopefully you can see it actually decreases like this, and it gets to be like that. And then similarly now, okay, so I guess I should try to highlight this, right? Or maybe not highlight. I'll just do that for now, okay? Similarly, for these, oops, I just erased. Similarly, for these values from negative pi over 2 to pi, okay, I'm looking at pi over 2 all the way to pi. But notice these values are negative, so negative means opposite direction. So I'm actually not going to draw them in quadrant 2. I'm actually going to draw them over here in quadrant 4. And noticing that the value of c is the coordinate pi and then negative 2. So that would actually get me back to, yeah, the same thing as a. So really, I'm now sketching it like this. Back to a, like that. Okay? And similarly, if I want to go to now the next component from C to D, that's really in the third quadrant here, but once again it's negative, so I'm actually looking at the opposite. I'm actually going to be doing this again. So I will take, oh no, I erased the first one, sorry. The first one's like this. Okay, so now going from C to D, I'll use green. And actually C to D just copies the path of the red path back to the origin D. And then finally, that last one here in purple, that's in quadrant 4. So now I'm just looking at all the angles in the fourth quadrant here. Yes, and notice these values are positive, so we'll stay in that quadrant. So ultimately here, I think you should be able to see that we're actually doing another copying of that distance in blue. So there we go. D is also the same part as C and as A. So what you've drawn here is actually a nice circle. Okay, a circle with radius 1, right? Okay, and it's on the x-axis. Now, you can use your calculator as well. So if I take out my calculator, I ask you to turn it on. Whoops, let me see that. If you had this now, remember how we can change it? It's the mode. Make sure you're in polar mode, P-O-L. And then we can go to R, and I'll just ask you to type in the equation. So the equation is 2 cosine, and then the theta button is the same thing as this xt theta. And see, the x is the variable for functions, t is the variable for parametrics, theta is the variable for polar, and n is the variable for the last one, which is called a sequence. Okay, so if I type this in 2 cos theta and I press graph, or I'll do zoom trig, notice that, oh yes, there it is. Boom. Okay, and if I can trace around here, look, my starting value when theta equals 0, the x is 2 and 0, so it gives you the rectangular coordinate. And notice as the angle increases, this is how it's actually drawing out the circle. Okay. And notice that once I get back one complete cycle, it's pi is 3.14. So this is equivalent to the point C. And then I can keep going. So here we go. Then here is the equivalent point D. And then we'll run back around to 2 pi. There we go. Okay, so 2 rotations around. Done. Okay, so this is what I'd like you to do now. And I want you to try to graph out the next one. So here we go. 11b. Same idea first, okay? Can you graph out y equals to 5 sine theta? Do that first, okay? Sine graph. I'm going to change the scale. 5, negative 5, okay? I'll label my points A, B, C, D, E again to help us, right? A, B, C, D, E, just to help you figure out what's going on and how it's being drawn. You don't necessarily need to use A, B, C, E, okay? It's easier for me to reference those points. Okay, so now A, that's the coordinates 0, 0, right? So origin 0, 0, angle is 0, radius is 0. Good. B, this is the coordinate, angle is pi over 2, the radius is 5. So 1, 2, 3, 4, 5. And then how did I get there? So once again, in this region, I'm looking at all the angles from 0 to pi. And notice that the radius, the distance changes from 0 to 5. So I will be getting bigger and bigger and bigger and bigger and bigger and probably out to here like this. Okay? Now, how about the next part? From pi over 2 to pi, okay, that's this region, these spokes. And notice that the y value, or in this case the r value, reduces and gets less and less and less. So ultimately, I think you're going to come back around like this. So let me call that B. Let's call this point C, which is also A. And then now with the remaining parts, so negative pi, pi to 3 pi over 2, that's this quadrant, but notice all those r values are negative. And notice at 3 pi over 2 then, down here, our r value is negative 5. So at 3 pi over 2, it's negative 5. That means it's up here. So yes, like the previous one, you're just going to copy it again and do another cycle. Yes, yes, yes. So if I drew this nicer, you would see that this also is a circle with diameter 5. Okay. And this one seems to be not on the x-axis, but yeah, cut in half along the y-axis. So I want you to realize that graphs of these forms where r equals to some value of a times cos theta or a times sine theta, the shapes you get are circles. Okay? And once again, you can use your graphing calculator to check that for you. All right. Number 12. So now what I've done is I've changed one small thing. Instead of it just being cosine theta or sine theta, now I have cosine 2 theta. Remember what happened in pre-calculus? What happened with that? Yes, the period shrunk. Good. Or this was a horizontal compression by a factor of half. So that's what you need to do. Okay, let's do this. Bum ba-dum bum ba-dum bum 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 bum. Bum, 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 bum. Sorry, just want to sing. Thinking about something else. Oh, someone's calling me. Why don't you try this then? While I answer the phone. Pause. Never mind about. Let's go 3 as the vertical expansion height. This time though, yes, we have to cut the period in half. So, cosine, right? Start. Yeah, that makes sense? Did you get that? Did you get that? Did you get that? Let's keep going, right? And if you're curious, let me call these points A, B, and by the way, that's pi over 4. C, and this is 3 pi over 4. D, E, F, which would be, what, 5 pi over 4. G, 7 pi over 4. H, and then letter I. All right. So remember here, note the period of our graph was cut in half. It's pi. All right. Let's see how we can graph this out. Here we go. Let's do this first part, A to B. So starting at an angle of 0, we are 3 units away. So 1, 2, 3. Boom. This is point A. And as we move, notice the radius gets less and the angle goes to pi over 4. So here is pi over 4, right? So here we're going to be back at the origin. So in this wedge, okay, notice that the r is reducing. It's decreasing, yeah. So hopefully you'll see that it looks like this, okay? So that part corresponds to the part I highlighted in yellow, okay? Now, look at the next part. From negative pi over 4, from pi over 4 to pi over 2. That actually is this wedge. But because the value for y, or r, is negative, we're going to be now in the opposite direction, right? So the graph actually will be in this region here. Okay? And it goes from 0 to -3. So at pi over 2, the answer is -3. So really, point C is down here. And to get to that position, we had to go like this. Okay? Let me just erase all my highlighting to make it nicer. Okay? So that's what we got. All right? Now let's think about this next part. From pi over 2 to 3 pi over 4. So pi over 2 to 3 pi over 4, that's this wedge here. But once again, our values are negative, so we have to go the other way. And what happens there? Yes, that radius now returns back to 0. So large going smaller, smaller, smaller. There you go. So our point D is actually the origin. So B and D are the origin, which makes sense because on our graph over here, B and D, the Y value is 0. Okay. Let's keep going. Okay, so from 3 pi over 4 to pi. So that's 3 pi over 4, that's here, all the way to pi. That's this region. Oh, thankfully our R is now positive again. Okay, so I can go to E. It's positive 3, so 1, 2, 3. There we go. So I'm thinking it looks something like this. Erase the highlighting again. Oh, how can we erase that? Sorry, let me put that back in. Okay, so this is now E. And then we'll continue with this part for pi to pi over 4. That would be this wedge here. And then, yes, that goes back to 0. So, whoop, back here, there's F. EDF, the same. And I hope you can kind of visualize what's going on next. So, from F to G, it's now 5 pi over 4. So, that's this one to here. But once again, negative value. So, flip it opposite direction. Here we go. G, F to G. 1, 2, 3, right? G. Here is G. And then we're going to H. And then I. Oops, what happened? G. And then H. Yeah, goes back down here. So H is also at the origin. And we'll finally finish this off by this last component here, which I'll do in yellow. Once again, this is the component from 7 pi over 4, so the wedge from 7 pi over 4 to 2 pi. And these are all positive values, so look, I'm going to close it off like this. And then we're back to A, which is equivalent to I. There you go. There's your shape. Looks like petals of a flower. 4 petal flowers. Okay. All right, I'm going to ask you now to try B yourself, and then yes, you can double check these with the calculator. I guess I'll show you this one with the calculator first before we do part B. Why not? Da, da, da. So Y equals to 3 cos 2 theta. So watch now as we graph. Dun, 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 dun. Boom, exactly what you just drew. Okay. So can you try 12B yourself? Okay, I will ask you to pause the video this time, and I'll just quickly do the answer, and hopefully you get the same thing, because it does take me quite a long time to just explain. And I do have 2 other ones I want to show you. All right, press pause. 3 theta, wow. So the period is, what, 2 pi over 3? 2 pi over 3. That's 4 spaces, right? 4 pi over 3, 6 pi over 3, yeah. It's 4, so that's good. So sine, so that's 4, -4. Another repeat, and a third repeat. Okay. Guess I'll label these points just to help. A, B, C, D, E, F, G, H, I, J, K, L. Ah, L. A, B, C, D, E, F, G, H, I, J, K. Did I miss a point? A, B. Oh, I did. Ah! Who taught me the alphabet? Ah. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Okay, all right. Here we go. A is 0, 0. B, which is at what? Pi over 6, right? This is pi over 6, is 4. 1, 2, 3, 4. Wow. Whoop. There we go. Okay. And then back to C, which is at 0, which is at pi over 3. So this wedge. Okay, so there's my A, B, C. And then D is negative. So pi over 2, 1, 2, 3, 4, negative. Down here, that's D. And then back to here, E. And then F. F. This is occurring at what? 5 pi over 6. So 5 pi over 6 F 1, 2, 3, 4. So that. And then that's F. And then back to G at pi is 0. There's G. Okay. And then H is negative 4 for the radius, but I'm looking at 4 pi over 3. No, not 4 pi over 3. Sorry, 5 pi over, no, 7 pi over 6, so that's negative. Oh, then you're just actually doing this. You're doing another copy of this. Yes. And there you go, back to normal at M. Okay, so if I did that copy again, A, B, C, D, E, F, G, H is the same thing as B, I, J is the same thing as D, A, L is the same thing as F, and then M is back in the origin. Okay, there you go. And graphs of these forms are called rose petal curves. Yes, you now finally know how to draw rose petals or curves on these polar grids. Okay. Notice here too, if the B value is odd, like our example in 12b, then you actually have only B petals. Okay, so in this case, 3 theta, 3 petals. Yet the weird thing is when it's even, you actually get double the amount of petals. You get 2 B petals. So just be aware of that. Okay? All right. Another long video, I'm so sorry, but I think it's just good to help you understand how these graphs come from. I think it's important to see how the connection is from the rectangular to the polar so that you can actually get a better understanding. I know you can just graph this on the graphing calculator, and definitely you can do that on the calculator portion of the test. But if it's not a question on the graphing calculator portion, then I don't want you to be messed up. Okay? Let me show you 13 and then A, and I think that'll be it. I'll let you try B on your own, and then 14 is the more fun one that I think you can try on your own too. But let me show you how to do this one. Now, I like, once again, graphing this out. Okay. I like rewriting this as y equals to, and I'll go negative 3 cosine theta plus 2. Okay. I'm just used to doing that when I teach pre-calculus. Yes, the graph is what? Starting at negative 3 to 3 if I have the basic graph, and it's reflected, so hopefully you remember that this is what the graph can look like. Okay, that's just y equals to negative 3 cosine theta, but yes, we have to add 2 to it. This is a shifting up 2 units now, so boom, boom, 2, boom, boom, 2, boom, boom, do, 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 do. And notice that now the value where it crosses the x-axis is a little bit different. Right? Now, If I actually wanted you to find out where these values are, well, we can just make that equation 2 minus 3 cosine theta equal to 0 and solve, right? So 2 equals to 3 cosine theta. Cosine theta equals to 2/3. Inverse cos of 2/3. Oh, that's not a nice number. Ah. But if you actually want to find out, fine. Graph and calculator. What? Inverse cos of 2/3. What do we get? 0.84. So yeah, theta equals to 0.84. That makes sense as this answer. And then where's the other one going to be? Yeah, remember all students take calculus. I want cosine to be positive, so it must be in quadrant 4. 2 pi minus 0.84, how about 5.45? Just if you wanted to know. You didn't really need to do this, but if you wanted to know, that's what it is. Okay, so now our goal is to see what this looks like as I convert this into the rectangular grid. Okie dokie. Here we go. Let me label some points. A, B. I'm going to label this point here C. This one up here D. E, F, and then G. Okay? Watch. When theta is 0, notice that the A value is -1. So we're not going this direction, we're going to the other direction. So here is A. Okay? When it's -1. Okay, to the left of the origin. Okay, now B actually comes back to 0. So the R value goes to 0, but notice the angle goes 0.84. So really what I'm saying is starting here and rotating 0.84, which is who knows how much, but that actually answer, or the R value is negative, so we're actually over here. We're going to try and get that back to 0, so something like this. Okay, so here's B now, back to the origin. Okay. And then now from B to C. Now C is pi over 2. So the next region I'm looking at now is this part here. And notice it's from 0.84, whatever that was, to pi over 2. And notice it's now 2. So I'm going to continue drawing this all the way so it touches here. Here's the 0.2, right? 2 comma pi. So that's C. Oh, did I just erase it? C. And we'll continue all the way to D. So when pi is the angle, the radius is huge. It's 5. So 1, 2, 3, 4, 5. Oh, it's right here. There's D. Do, 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 do. And then back to E. What's E? 3 pi over 2 and then 2. So I guess that would be right here. So E. Oops. Didn't really draw that really curvy enough. E. I'm having a hard time drawing a nice E. And then going from E to F, you'll hopefully see that it gets closer back to the origin. So there's F. F and B are the same point. And then this last particular part, notice how I'm going from whatever that angle is back to 2 pi. And it's going to be negative, so we're going in the opposite direction. And notice it just closes it off. So A and G are the same point. Okay, so you get this kind of shape. Kind of weird thing with like a little loop inside, but yeah, that's what you get. Okay, now your turn to try number 13B. Okay, and I definitely want you to do that. All right, have fun. Y equals to 3. What's my equation I want? Y equals 3 sine theta plus 3. Wow. So 3 sine theta would be like here. Plus 3. Oh boy, 3, 4, 5, 6. Yikes. 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 Oh, interesting how though the R value in this one is always Positive. Okay, good. None of that weird, like, opposite direction stuff. Well, that's nice. That's nice. That's nice. Okay. A, B, C, D, E. Let's do this. A is angle 0, 3 units away, starting here. There's A. B, wow, 6 units away. What do I 6 off my chart? Okay, so probably like this. To B, and then to C is pi. Pi is 3, 1, 2, 3. So maybe back here is C. And then D, interesting. 3 pi over 2 is actually at 0. So, let me draw that again. Makes it more curved. You get the idea. Let me try again. And then more curved back to D. D is at the origin. And then what happens here from D to E? Oh, interesting. So that's 3 pi over 2 to 2 pi. That's this region. It's positive, and it goes to positive 3 in the end. So ultimately, it stays in quadrant 4, and then here, A is equal to E. So I hope you get some picture that looks like this. Okay. Graphs of these forms are called Limacons. Limacons. Or sometimes the one that doesn't have a hole or a cusp here like this, which is 13b, is called a cardioid, kind of like a heart, okay, right? So also understand that I hope you can see that cosine one has what they call x-axis symmetry. It's, yeah, you can cut it along the x-axis and get 2 equal halves, whereas the one where sine occurs has y-axis symmetry, okay? All right, that takes care of 11, 12, and 13 in your notes. I know there's also example 14, the Lemniscate. You can think about that if you want. This is a r squared, but not to worry. I can just say r equals to the square root of 9 sine 2 theta. This does say you can use a calculator, so you could try this with a calculator if you want to draw it out, or you can try this by doing the old-fashioned way without. Both should work. And just to let you know, if I were to do this, I think I get something like this, okay? Whoop. And then this value here, I think is pi over 4 and 3. And then you get something over here, whoop. And then this value over here, I think is negative 3 and, oh, sorry, it's not negative 3, my fault. There's no negatives, right? Square root can't be negative. I think this is positive 3 and 5 pi over 4, okay? So hopefully you can do this well yourself. If not, use the graphing calculator and then trace around to see what happens. You'll find something interesting there too. Okay, that's it for part 2. Okay, now after learning all this, we can actually do some calculus with polar coordinates. So come back when you're ready for part 3.